Hello friends, welcome to another video of Zeta Axis, and today we are going to discuss about steel production in India. In our previous video, we have seen the iron ore reserves of India, and in this video we will see how steel is produced from iron ore. So let's first differentiate between steel and stainless steel. We have heard both of these names quite frequently. So steel is made by adding iron to carbon. So it is an alloy of iron and carbon. These are the two important things where iron is almost 90% or 98% and carbon is in very small amount. The carbon gives hardness. While stainless steel, it is made by adding iron, chromium, nickel, molybdenum and carbon. So we can see that chromium and nickel, they provide the anti-corrosion feature to stainless steel. So this is not resistant to corrosion and this is generally slightly reddish color, while this is resistant to corrosion and it has a shiny surface. All the utensils that we see in our kitchen are mainly stainless steel. However, steel is stronger than stainless steel because it has higher amount of carbon, while stainless steel is less stronger than steel because it has lesser amount of carbon composition. Now this is basically the process by which steel is made. Here we see that there is iron ore and here we have coal. This is good quality of coal. So iron ore is sintered, that it is made into smaller parts, and then this is coal which is converted to coke by heating it without oxygen. So this increases the carbon compound and reduces the moisture from the coal. Now both of these along with limestone are mixed in a blast furnace or blast oxygen furnace, and here we get a slurry which is pig iron. This pig iron then can be used in blast oxygen furnace to make steel. Similarly, there is another process where we use the iron ore for direct reduction. We will see this process later in the slides. So after direct reduction, we get sponge iron, and this sponge iron is then used in electronic arc furnace, and from here we get steel which can be processed to make whatever finished product we require. Now to understand what is pig iron, let's see the production, how it is produced. It is produced in blast furnaces. This is a blast furnace and we are adding iron ore, coke and limestone. All of these are added and it is heated at a very high temperature. And what we see that slag is found, that is the impurities are on the top and iron is heavier, so it is collected at the bottom. Iron can be removed from here while slag can be removed from here. This iron that we get is generally pig iron. Now it is obtained from iron ore, coke which is a carbon source and limestone which is a flux. The carbon content is very high carbon content, typically between 3.5% to 4.5%. It contains impurities such as silicon, magnesium and sulfur. The major impurity in pig iron is graphite. It is brittle and difficult to work with because of high carbon. It is brittle. It is crucial component in the production of steel. So pig iron is not directly usable. It has to be converted in some other form of iron or steel before it can be used. So this is basically a raw material for production of either other types of iron or steel. So here we can see that pig iron is used for making wrought iron, steel or cast iron. And these are the differences. It contains less carbon than steel. It has maximum 0.15% of carbon. Now this is achieved by taking the pig iron and heating it in the furnace. When we heat it in the furnace, the carbon, it gets burned or consumed, and therefore the quantity of the carbon is reduced. Now while making wrought iron, it is never heated above the melting point, but the iron is always heated below the melting point. This is the older method of making iron. Most of the ironsmiths use this kind of iron in their production chain. Then is cast iron. Here it contains more carbon than steel and it contains 2 to 4% of carbon. Here the pig iron is refined again and again by either adding some things or repeating the process, and therefore we get good quality of iron. This is more pure, and this can be used for casting because it has higher carbon, it is more harder, and it can be used in making things. And then we have steel, which has carbon of 0.15 to 0.25%, but it can be up to 2%. So let's see what is sponge iron. In the video, we see that there was an electronic arc method of producing steel which used the sponge iron. So the sponge iron or direct reduced iron are the same thing. Here we directly take the iron ore and it is heated at temperature below the iron melting point. We put the iron ore in a furnace and heat it at a temperature below the melting point. Here, reducing gases are used like hydrogen carbon monoxide to remove oxygen from the iron ore, resulting in a porous, remember, porous spongy iron material. So when you see this kind of output is the sponge iron, and here you can see that there are certain holes on the surface of these irons. That is why it is called sponge iron. Here is the process. So we can see that low grade iron ore pellets are put in the furnace and they are added reducing agents. And what we get in the output, it has higher content of iron because oxygen is reduced from this iron ore content, and that is why we get slightly good quality of iron. However, sponge iron is also not directly usable, but it is better than pig iron. Now let's see what is cast iron we have seen earlier. So it is made from pig iron. We have seen how pig iron is produced, and it can be made directly from the molten pig iron or by remelting pig iron. So it can be directly produced from molten pig iron. It can be further refined. Cast iron is made by melting iron and adding a combination of scrap iron, steel and limestone. So we can add the scrap iron and steel which we have made earlier for further strengthening the iron. Pouring the molten cast iron on casting molds for cooling and hardening. So the molten iron, which is a cast iron, is then put into the cast of whatever you want to make, and then it is allowed to cool down and it is hardened. It has high carbon content, more than 2% of carbon, making it hard and brittle. It has higher carbon content, which makes it very hard. And it has excellent castability, means you can cast it in any shape. Therefore, it is easy to mold the metal into complicated shapes since it is quite fluid when melted. Now, what is wrought iron? So, an iron alloy with very low carbon content, less than 0.05 or even slightly 0.15%. So, it has very less quantity of carbon. Wrought iron is manufactured by heating and melting high carbon cast iron in an open charcoal or coke earth or furnace in a process known as puddling. Higher temperatures causes the excess carbon to oxidize. So remember, in pig iron we have higher content of carbon, but when we heat it, then the excess carbon is removed. As the carbon content reduces, the melting point of the iron increases. Now, wrought iron over cast iron is its malleability. That is, cast iron is not malleable. That is, you cannot make it into different shapes by heating it. But it can be cast into different shapes only by melting it and then pouring it into the cast. But wrought iron can be hammered into different shapes. So it is very malleable. Cast iron is too brittle because it has high carbon content, therefore it is too brittle to bend or shape without breaking it. Well, wrought iron is highly malleable. That is, it can be changed into different shapes by hammering. And that is why the ironsmiths will generally use this kind of iron. Now let's see steel production. We have already seen this slide where we can see that steel can be produced by two main methods. One is blast oxygen furnace where pig iron is the input, or electric arc furnace where sponge iron is the input. We have already seen how we get the pig iron and sponge iron. Scrap can also be used both in blast oxygen furnace as well as electric arc furnace. So these are older materials which are not useful, can be recycled. Here is this process in detail. We can see that iron ore, limestone and coal are used. These are the basic inputs. The iron ore and limestone are put together in a sinter plant. They are broken down into smaller parts. The coal is converted to coke in this coke plant. The output we can see sintered ore, that is, they are broken into very small parts, they are mixed, and here is a coke. And then we put it into blast furnace. We heat the blast furnace, we get pig iron. The pig iron is again converted, some iron scrap is added, and then it is refined in the method, and then it is molten down, and this molten steel is used for making different kind of output products. The four main methods can be seen over here. One is blast furnace, second is smelting reduction. In both of them, we see that blast oxygen furnace is used. And these are the inputs, oxygen, furnace. We can see this process, right? We do not need to get in extreme detail of this, but we can see that there is smelting reduction, blast furnace reduction, direct reduction, which produces sponge iron. And this sponge iron can be put into electric arc furnace to produce steel. And then we can use scrap. This can be recycled to produce steel. So these are the four main methods by which we can produce steel. So remember, here we have coke, this sinter plant from which iron ore and limestone is added, and then we get pig iron, which is then again put into blast oxygen furnace. Here is again some smelting reduction process there, some reducing elements are used for producing intermediate iron ore, and then it is again oxygen and scraps, and this hot metal from here is added to get steel. And then here sponge iron is used, and scrap can also be added, and here directly scrap is used. So if we see the steel production data, this is a little old from 2022, but it still holds good. So if we see, most of the steel production occurs from Odisha and Jharkhand. Then we have Karnataka, Chhattisgarh, Maharashtra, and then there are other states of Andhra Pradesh, Gujarat, and West Bengal. Here in this chart we can see Odisha is the leading producer of steel in India, followed by Jharkhand. Then we have Chhattisgarh, then we have Karnataka, and then we have Maharashtra and Gujarat, and so on. Here are the steel plants located across India, and we can see that large amount of steel plants are located in this region because we have coal over here as well as iron ore reserves in this region. So both of the most important inputs for steel plant are available over here. That is coal, which is converted to coke, and iron ore. So both of them are present in close vicinity. Now these are the cities where this steel plant is located. You can see the names. I'm not going to name all of them. And these are the areas where the circle area indicates the amount of production in that region. So if we see, most amount of steel production occurs in this region. Odisha alone produces large amount of steel in this region, and then we have the Jharkhand and West Bengal, which also produce large amount of steel. And then here in the Bellary region we see large amount of steel production. In Maharashtra also, on near Goa I think it is, that there is JSW plant over here of Jindal Steel, and then here also in Hazira we see good amount of steel production. Here are the name of these regions. So we have Bellary over here, Koppala, Tornagulu, Vizag, Pradeep, Kendrapa, again Pradeep, there is another plant. So these are the plants. We have Bokaro, Jamshedpur. Jamshedpur is an important region which produces steel. And these are the name of those companies. We can see here Tata Steel is there in Jamshedpur, JSW, that is Jindal Steel, SAIL. Here we have Mittal plant in Hazira, Surat. Then we have JSW, that is Jindal Steel in Pen near Mumbai. And then we have other industries. So you can there see the names of those industries. Here again in Bellary we have JSW. So within the eastern sector we can see that large amount of steel is produced in Odisha, West Bengal, and Jharkhand. These are the name of the cities. So if you want to remember the specific names, we can see that Ranchi, here Jamshedpur, Salboni, Pradeep is also a very large producer. Then we have Kendrapara, so this also produces. Even Bhilai is there where we can see that steel production occurs. And again, these are in detail the name of those plants which produce steel. So here we can see that in Paradeep we have Mittal, Nippon Industry, and JSW. Both are there. Even SAIL is there. So 3 steel industries are there in Paradeep. Then we can see here that there is this Tata Steel as well as in Jamshedpur, and close by we have Jindal Steel. So Jindal Steel is also in Ranchi. So here we can see all the industries. Even here we can see Vedanta. Here in southern India, we can see the cities where iron steel producing regions are located. We have Vizag, Salem, Then here we have Bellary. Bellary has 2 or more plants, and these are the other regions which are smaller producer of steel. These are the name of the companies which produce steel in this region. Then we have the western states which produce steel, and here we can see Hazira and Dolvi or Salavi here in the Maharashtra. These are the two main regions which produce steel in western states. Hazira, Dolvi and Konsari. And this is operated by GSW. This is operated by ArcelorMittal, and this is by Lords Metal and Energy. So I hope now you have a good idea of the steel producing regions as well as steel producing companies in our India. I hope you liked the video, and if you have liked the video, then do subscribe to the channel and share it with your friends. And if you like what you are doing, then you can help us by using the Paytm ID over here. Thanks for watching the video.